Yeah, I'm not truly motivated to do it, but I'm still gonna do it. Still putting in the hours. That's how the grades were made. I'm gonna be one of the best programmers slash engineers in the world, and it's it's what it is. I'm gonna be one of the best programmers in the world, and you guys have to just stand back and watch. I don't want to do this. I actually don't want to do nothing today, but I'm gonna do it because I'm chosen by God to do this. By Jesus Christ, the Son of God, and the Holy Spirit. Okay, where was I the other day? I should I should have made a mark. Okay, I'll start. Okay, we present Z Image Turbo, which delivers exceptional aesthetic alignment and highly fidel- fidelity visuals in only 8 number function. So wait, I need to get something. No, you don't have to. Don't worry. Don't worry.
All right. So
Apparently, this is like the. How do I add group? New group. It's gonna be called Papers. Yeah, I think you need to make a lot of money, mate. That's it. Efficient interference. Okay, what is reinforced learning by employing distribution? So DM she nigga she. Nigga if it okay. Okay. Bro, it's all clusterfuck. Oh my god. I don't actually need this. I think I can live in a cold. Building upon this robust foundation. Okay. Can you? I don't want to summarize, man. You can go, please. He's gonna summarize the entire thing. Oh, fucking. Don't do that. Don't do that. Summarize. Building upon. Okay. 8-number foundation NFEs. This performance is unlocked by the synergy of two innovation decoupled DM. The fuck is this? Decoupled. Which explicitly disentangles the quality of enhancing the training stability roles by distilling the process DMR, which integrates reinforced learning by employing the distribution matching item, which intrinsically regularize. Together, these techniques enable highly efficient generating without bidding Sweden. Okay, DM. Okay, couple in this paper is in few steps, distilling the model method that separates the students from learning trajectory, how it's learned from the final image. Purpose. The goal is to make the steps simpler into fewer steps, the Z image turbo, while preserving the quality and quality. So it's like an iterative step. Decoupling lets the model first match the teacher's diagnosis, the dynamics, then specializes for. Okay. What is? Decoupled DMV, decoupled identity proof composure.ai.
My name is Khalid and I am a member of the engineering team at Composure. In this video demonstration, I will show you how Composure securely decouples user
Go on, don't stop talking.
Hi folks, securely decouples user identity providers from cloud provider system. This slide shows overall architecture of the decoupling process. Composure can support multiple identity providers for more than one cloud provider system. It also supports most of the conventional identity providers such as OAuth and SAML. Composure provides very simple APIs to onboard cloud providers' account information and to add supported identity providers' information. These information are protected by storing in encrypted files, and then users authenticated by an identity provider can log into the system and perform operations to a particular cloud. Now, let's see how it is actually achieved in Composure. First, an admin user onboard a cloud provider to Composure and validate that the cloud provider's information is encrypted. Then, users will log in using different identity providers.
Okay, fine. Speed and quality. Building upon this robust foundation of efficient workflow, we have successfully derived the two-step civilization variant that addresses the distinct application needed. First, few distillations screen with reinforced learning. So we have foundation of workflow have successfully derived two specialized variants of addressing distinct application needs. What is each variant is tailored for distinct application needs are fast, low latency, fast distillation scheme, learning reinforced turbo, and an accelerated model achieves exceptional aesthetic alignment in just 8 NFEs. It offers sub-second inference latency and fits within the memory constraints of the consumer grade. Second, we have two different fork in the road. One of them is reinforced schemed with RL. Learns, yields, turbo accelerated model achieves exceptional aesthetic alignment in 8 NFEs. It offers sub-second inference latency on enterprise and GPU and fits within the memory constraint of consumer-grade hardware. 16 GB. Two app needs, application needs. And second, leveraging the multitask nature of the Omni pre-training, we introduce Z image edit, a model specialized precision instruction to following image editing. And an extensive quantitative experiment demonstrates the superiority of Z image family in an illustrated figure. Can I do that? Cool. And delivers, let's look at this. Image delivers strong capabilities of photorealistic generation, exceptional bilingual Chinese and reading, rendering, matching the visual field, much larger models. Figure 3 showcases the capabilities of Z edit. This is the edit, and this is the bro. It's fucking sick. You can just do that. You just type out a prompt. How cool is that? Okay, this is like a re-editing. You can just re-edit in all of these different ways. So those are the two simple paradigms we live in. I mean, simple. We are creating image from the ground up, or we are just using it to edit it. Showcases the comparison. To edit instruction, furthermore, quantitative comparison in figure reveal our model rivals the top commercial systems, providing the state-of-the-art results achievable with significantly reduced computational overhead. We publicly release our code weights and online demos to foster the development and of accession. But okay, cool. Data infrastructure. While remarkable capabilities of the state-of-the-art image-to-text models underpinned by large-scale training data, achieving... So, okay, what is the first one? The first one will be introduction. These are the general... They're using RL for reinforced learning for image generation, and state-of-the-art for image editing the images, like tokenized form. So data infrastructure. So AI infrastructure. I need to look at AI infrastructure. AI infrastructure. Explain.
Welcome.
No. AI hardware. No. What is AI inference? I don't give a fuck. The secret
What
of AI
is inferencing?
No. Okay. While the remarkable capabilities of state-of-the-art image tool are underpinned by large-scale training data, achieving and underperforming constrained computational resources necessities a paradigm shift from data quality to data efficiency. Simply scaling the data size often leads to diminishing returns. Yeah, I can see that. Instead of can we draw diminishing returns? Whee! Per computational scale, simply scaling. Okay. To end the idea, data system must strictly be curated, conceptually broad, yet non-reluctant, exhibit robust multilingual image-text alignment, okay, and crucially be structured by dynamic curriculum learning to ensure the data composition evolves the match to the model training stage. To realize this, we have designed the implemented and integrated efficient data infrastructure. Far from static repository, the system operates as a dynamic engine architect. Dynamic system, okay, to rate of acquisition within the fixed training budget. As a cornerstone of our pipeline, this infrastructure composed of 4-layer synergistic module. So data, so this. Infrastructure. Okay, we have infrastructure. The fuck? Okay, 2.5 different layers of infrastructure, I think. But there's only like 4 here. Active. Do we? Okay, we have 5 different things. Image. Caption here. Okay. Using like a caption for the images. Okay. Data profiling engine. This model serves as a quantitative foundation for our data strategy. It extracts and computes a rich set of multi-dimensional features from raw and spanning low-level physical attributes to a high-level semantic properties. These computed profiles are merely for basic filtering. They are not essential signals used to quantify data. complexity and quality, enabling the programming construction of curricula for a dynamic learning stages or proper what the fuck. Curriculum learning, data centric AI for deep learning data sets. Data centric AI, MIT Introduction to Data Centric AI. Women in ML, bro. I don't give a shit, bro. Just I'm actually the first woman in ML. No one gives a fuck.
What's data-centric AI? Usually in machine learning, what's data-centric AI? Usually in machine learning, you try to produce models for a given data set. But in real-world applications, data is messy, and just refining the model is not the only way to get better performance. You can also improve the quality of the data set itself. Data-centric AI is an emerging science that studies techniques to improve data sets, which is often the best way to improve performance in practical ML applications. MIT just released a free course on data-centric AI. Check it out. What's data-centric AI?
All right, good to see everybody. I just flew in from SF, where I've been the last 2 years.
Okay, now we talking. Data prolific engine, data centric AI, data prolific. This model saves a quantitative function for data strategy, data text computer, rich multi-dimensional features for raw data, spanning low-level physical attributes, image, metadata, clarity metrics to high-level semantic properties. These compute profiles not merely for basic filtering, they are also signaling. Okay. Cross-model vector engine. Data profiling engine is engineered to systematically process massive uncurated data pool, compromising large-scale internal copyrighted collection. Oh shit! Let's start copyrighted collection. It computes a comprehensive suite for multi-dimensional features of each element text pair, enabling principal data collection. I just wanna like, what the fuck is that, bro?
Hi everybody, can you guys hear me okay? Cool. I'm Jonas, and hope you guys have been enjoying the class so far. At least you are back, so that's a good sign. In today's lecture, we're going to cover sourcing data, and really like how do we think about, where do we get data from? Where do we get it labeled? How do we make sure that we are, curating the right data for machine learning, which is, the foundation of everything that we're going to build in an AI product or machine learning application will depend on the data that we're sourcing for that application. And so we're going to start with some key questions here.
Cross-model vector. Okay.
And so the two things you should always be thinking about when you are even at the very beginning of any machine learning project, before you even have any data, is how will your model be used? Hi, everybody. Can you guys hear me okay? So really,
Cool.
that means like
Jonas,
what
and
population are we
you guys
going
have
to
been
be
enjoying the
making
class so
predictions
far.
on?
At least
At
you
what
are back,
time
so
are these
that's a good
predictions
sign.
going to be made, right? Like you really need to think about that end use case and exactly how everything will happen, and that will really inform the right way to collect your training data. And then you'll really want to also think about like hypothetical, I'll just call these hypotheticals, but things like edge cases, high stakes scenarios where you really need the model to make the right predictions, specific cases of how it will be used that are more important to think about than others.
Data curation. What is the point of this? Ow. Ow. Wall knowledge topographical graph. Oh shit. Vector database. What the fuck is a vector database? Ooh, that's so sweet. Okay. Yes, there is a full course. Okay, deep learning and computer vision. Nah. Cross embedding models. What is a cross? Multimodal and cross embedding models. Okay.
Nice and cozy. So hi everyone. My name is Louis Philippe, but don't worry, became LP or Professor LP if you want, if you prefer. I will be co-teaching, co-lecturing this class with, I got to plug this. 1 2 1 2 test. Yes, okay. Just want to be sure we had some fun issues last time. Good. Okay, we're all set. So I will be lecturing this class with Paul Leon. I'm so happy. In fact, you're lucky because this is his last time doing it with me. He will be graduating this year. He has been remodeling completely this class with me over the last 2 years, and so I'm really glad he's accepted to do it one more time. This course is also taught in the spring, so if you're on the wait list, and I will get that answer, although in theory only the people who are registered should be in the classroom right now. Oh, here, Paul is in the back. Okay. Yes, okay, good. So if you're on the wait list, we're really hopeful. Usually within a week or two, within the first week, we know how many more spots will be available. We will cap it to 100. This is the room capacity, and we have some presentation at some point in the midterm, so we need to have room capacity. But there is also this time in the spring, have a presentation at some point in the midterm, so we need to have room capacity. But there is also the same course taught in the spring by probably Jonathan and Daniel, although I don't know if it has been confirmed. We also have 5 TAs, and we select the TAs very carefully because they're very key to this course. Because a big component, as I will discuss later, is the course project is a big component of this class. And you will work very closely with the TAs and with us on this. So I don't know if any of them are anything. Oh yeah, Sienna is here. Any other? No, thank you. So we have at least one of the TA here, and you will meet the other ones over the course of the semester. Great. So I will do today a split of 2 things. We'll discuss multimodal, specifically multimodal machine learning, kind of an overview of this, and I will also after that give a syllabus of the course. For people also, you should have been already registered to Piazza and Canvas for this class. These are the 2 tools we will use primarily for this course. Canvas for this class. These are the 2 tools registered to Piazza and Canvas for this class. These are the 2 tools we will use primarily for this course. So, you're taking a multimodal course. What is multimodal? Do you know? No? Okay, fine. That's it? You don't know multimodal? What is multimodal? The simplest definition of multimodal you can think of. Yeah. Yes, exactly. So multiple modalities. And in fact, often when you think of modalities, you think of the modalities that are associated with human modalities. So the obvious one, you will have vision, you'll have sound, you have touch.
Is this completely useless? Multimodal AI unleashing.
These multimodal models tend to be much better at recognizing patterns, weak signals, and such. And so one of the things that people always, it's so interesting that AI has been so deep in your company. You've been building GPU infrastructure, running these large recommender systems for a long time. Now you're
a little slow on it, actually, getting to GPUs.
Yeah, I was trying to be nice.
I know. Well, too nice.
And these multimodal models tend to be.
Bro, he got the Junos. The Junos. You are a Jew.
I will be keeping the mask on. No.
Bro, mask on 2023? Maybe it's recorded in 2021, maybe, I don't know. Bro, it's not, what the fuck? Are you a bitch? Who the fuck are you? I want to see you. I guess they got a paper too, TA.
So negative on everything, but just because of CDC, of proximity, I want to be safe, and so I'm wearing the mask for that reason. Giving a lecture with a mask. Feels like 2 years ago. Okay, yes, so a pleasure because last week on Thursday we talked about the transformers, and now we're going to talk about the multimodal version of that. And I really want to thank all of you for the first project assignments. We have already started reviewing them yesterday. We had a TA meeting, and on Wednesday and Friday, I believe almost all teams, I think only one team didn't sign up yet. But it's going to be fun to talk to all of you. I already started reviewing the reports, and I will take some notes so that when we meet, we'll talk about primarily your research ideas. And the goal is not to solve them, but start giving you more pointers. And also to help with this is the second project assignment. And I know you just finished one, you're like, but the general idea is instead of having those homeworks on random data sets, we decided to have all the homeworks all on the
Bro,
same
this
data
nigga's 50 years old. Net worth. Gotta do a net worth check. Fuck. How you get that old, bro? Estimate, please. It's like, yeah, I get it, but it's like, golly, bro. Look at, bro, this nigga's like graduated advising. All these, okay, these guys are like advising. So he's teaching here, multimodal effect. Looks like pizza. We all know what pizza means. What these guys do, bro. These niggas, bro. So what's Steve? Does your fart smell know if you're depressed? Kinda. they know it. What kind of stupid question is that? Of course they know. Anyways, let's look into this. Cross-model vector engine built on billions of embeddings. This model engine is ensure the efficiency and diversity, directly supports our goal and non-reductant data set through large-scale semantic duplication. Furthermore, is a cross-model search capabilities, critical diagnosing for. Okay, this allows to pinpoint the prune data responsible for specific failure case and strategic sample for the conceptual gap. World knowledge topographical graph. What the hell is this? What the helly?
You
Bro, Chinese. I think he was in the Lex Friedman podcast, I think. It's like so goy slopped, you know. Oh, bro, people are. I'm pretty sure Lex Friedman has like a podcast with them. No? High modality multisensory AI. What does it do? Multisensory strong weak. Okay. Where's that passage? This allows to pinpoint the prune data. Okay. Wall knowledge. Topographical, this structure knowledge graph provides a symmetric backbone of the entire infrastructure. Okay, it basically underpins the entire goal of conceptual breadth by organizing the knowledge hierarchy crucial for the topological function as semantic compass for the data curation. It also allows us to identify the fill in the conceptual void in our data set by traversing the graph to find the underrepresented entity. Furthermore, it provides the structure framework needed to precisely rebalance the data distribution across the different conceptual training to ensure the more efficient comprehensive learning process.
Way, right? So this gives you the final representation we'll talk about for objects in 3D. So I've introduced voxels in a kind of complex way, but from a different perspective, people may say this is actually very easy to understand because in some sense, voxels actually have a lot of analogy as pixels because pixels are like 2D matrices. And now you have a 3D matrices, and voxels is basically just a 3D matrix, right? So although you can see that they have connections with all the other ways that we can represent shapes.
And then suddenly we come into the deep learning. And why is the deep learning era so important for multimodal? Because there's some landmark work, and
This European man needs a raise. He needs a raise, brother. Ontological engineering, what the fuck? Information reveal, graph-based ranking, retrieval. Okay, information retrieval, like the search engine.
started in the US.
Brother. There's like so many different ways to do it too. Convolutional neural network. Stanford School of Engineering, brother. Too elaborate. Nah. Waste of time. Not really waste of time, it's just too much. But feedback loop in the model mistake drives to new data. Okay. Oh, it's ML ops basically. It's ML ops. Let's write that down. Ops P ML ops. Crazy. Ow. Image data. We begin to cache the fundamental properties for image. This includes elementary metadata like resolution, width, height, file size with facilitate efficient filtering based on resolution aspect ratio. Simultaneously, we compute the perpetual hash p hash from the image beam stream. This hash acts as a compact visual fingerprint, enabling rapid low efficient low level duplication to remove identical or near images together. These pre-computed attributes from the first layer data selection. Okay, this is data pipeline. Okay, is this one? Multimodal machine learning. Data centric. What the fuck is data centric? Okay, let's technical quality assessment. The technical quantity of image is critical determinant of model performance. Our engine employs multi-faceted quantity. Okay, low quality asset. That is the cross-vector engine, data profiling, and world knowledge graph. Bro, what the fuck? Okay, string loading profiles. Profile path. Okay. Bro, why you spazzing out, bro? What the hell? What the hell happened to that? So we have networks as pandas, space, C, numpy, iter tool combination, typing collection. Okay, pandas. Okay. Not class on the knowledge graph in itself dot profile path, active curation. Okay, all of these things. Self dot iteration, curation state. This is the state for curation. Fuck me. The fuck, bro. For construct info under rep. Got like, what are these for loops, bro? So many for loops. You can optimize that for sure. Look at it, bro. It's like, how many for loops do you need? Oh my god. I think it's all embeddings and whatnot. So we have architecture different. Architecture, modeling, training architecture. Okay, that makes sense. So I think the main drawback in all of this is, can you go away? Yep. Bro, this nigga's cooking. The fuck? The fuck, bro? Profiling dot. Can you just like not do that, please? But just download it, please. Download everything. What the fuck am I supposed to do? Can you just download it, please? Bash, I think it's Bash. Fuck me, I'm so lame. Ubuntu, maybe? Nah, not even Ubuntu. Kill terminal. Bash. Fuck. Look at that. Come on, let go. What the fuck? Okay, PD is pandas. Okay. Bro, program. create a virtual environment. Okay, Python 3 virtual environment. Where XEX package you're trying to install. If you wish to install non-Debian packages, Python packages, create a virtual environment using path. Why do I have to do that? Python 3.m. I'm gonna crash out of this. Falls back again, but it will not, because unable to create a directory. Why? Why can't you do that? Could not be resolved. Could not be resolved. Why is there a lot of delete the old VM? What the fuck? Check the Python interpreter and VS Code. Press Command Shift P. Developer reload window. verify package. Nah. Me. I'm such a. Just make it work, little bro. Just make it work, please. You can create sample data set, data ends. Okay, it's just like a sample data set. Okay, cool. Download Coco. What the fuck?
In this video I'm going to show you how to quickly learn PyTorch in 3 easy steps. PyTorch is a deep learning framework developed by Facebook AI Research, and deep learning frameworks abstract away from you certain implementation details like how to construct a convolutional layer or linear layer, or how to do a backpropagation. It ends up with you calling a single line like loss dot backward, and that's it. It calculates the gradients automatically for you. So it's super popular in the research community. Most of the papers published on the biggest conferences out there for deep learning, for computer vision, NLP, etc. are using PyTorch. And allegedly it can also make your eyesight better and your skin clearer. So how can you learn PyTorch? Step number 1. The official PyTorch tutorials are actually pretty decent. You should start by going through this deep learning with PyTorch, a 60-minute blitz. It's going to teach you the basics of the framework. So this chapter, what is PyTorch, is going to teach you how to instantiate tensors, how to create like tensors of zeros, of ones, random numbers, how to convert between NumPy, back and forth between NumPy. But it's actually the syntax, it's really similar to NumPy. That's why one of the reasons why PyTorch is so popular. So secondly, it's going to teach you some of the basics behind what happens when you call backward, i.e. when you do backpropagation. It's going to teach you how to construct a really basic neural network and define the loss and everything. And finally, training a classifier is going to teach you how to do an end-to-end small deep learning pipeline, and that's super useful. So after you're done with this 60-minute blitz, just feel free to skip the second 2 chapters here, learning PyTorch with examples and what is TorchNN really, as that one goes really into depth of how to construct those yourself and have a better understanding, but you won't need it to start developing your own neural networks using PyTorch. So just feel free to skip it for now. Visualizing models, data, and training with TensorBoard, called Understanding PyTorch with an Example, a step-by-step tutorial. And it's super structured. You have it all in one place. Just go end to end, and you'll learn a bunch of stuff like about data set class, data loaders, how to create your own training loop, how to build your own simple network, class, and everything in a single place. Really nice visualizations, really nice writing. Super recommended. It's a bit longer, but you'll finish it in a couple of hours, and you're pretty much ready to start doing your own projects in PyTorch. And the third step, just start coding in PyTorch. So I have a couple of PyTorch projects on my GitHub, and you can take a look at this DeepDream repo. It's a super good way to start understanding how PyTorch works. And if you go to this playground.py, you'll find this function called understand PyTorch gradients, and it will help you better understand how the computational graph structure works behind the scenes. And also this one, DeepDream Simple, will also kind of clarify how the whole gradient update works, which usually your optimizers do behind the scene, like Atom, SGD, whatever. Is just being explicitly written down here in the code. So aside from going through that code classification, go ahead and write it down yourself from scratch, and you'll learn the syntax, you'll understand how the whole pipeline works, and that's pretty much it.